Hey everybody, welcome back. This is the third video for organic chemistry, and now we're going to start to look at different types of functional groups of organic compounds. So basically, last couple videos we talked about simple hydrocarbons, something called alkanes. And just as a reminder, an alkane would be something like, for example, CH4, which is methane, or C2H6, which is ethane, or C3H8, which is propane. And those are just carbon and hydrogen. And we're going to talk about alkenes and alkynes, which again are just going to involve carbon and hydrogen, but they're going to have something a little bit of a difference. You may have noticed with alkanes that there is like a general formula that we could come up with. So if you notice that for every carbon that we have to have a certain number of hydrogens. And I'm not sure if you noticed the pattern, but for the number of carbons we have, I'll call it N, so Cn, I'm going to have 2N plus 2 hydrogens. So for example, when I have C2, 2 carbons, then I have 2 times 2 is 4, plus another 2, 6 hydrogens. And that's always the case because alkanes are what we call saturated. And what that means is that every carbon is bonded to as many single other things as possible. The carbon might be stuck to another carbon, or it might be stuck to a hydrogen. Now an alkene I should say, is going to contain a double bond. And because it's got a double bond, and that double bond has to happen between the carbons, because remember, hydrogen will only take one bond. So the double bond between carbons means, well, if those 2 carbons share an additional bond, then they can get rid of 2 hydrogens. They can kind of just shed those. And so the general formula for an alkane is going to be CnH2n, because we've dropped 2 hydrogens for every double bond. So they are unsaturated. And by unsaturated, that means that there is a double or triple bond somewhere in the structure. And that double bond is a site for reaction. So what we'll learn is later on, if you want to undergo a chemical reaction and you want to attach like an oxygen or maybe a chlorine or something to a carbon chain, well, you might look for that double bond. And wherever the double bond is, that's where the reaction is going to take place. So we're going to follow the same rules when it comes to naming our alkenes with just a couple of twists. So the first thing to recognize is that we're going to have the same prefixes. So if there are 2 carbons in the alkene, then the prefix is still going to be eth. And that means it would be an ethene molecule. So all we do is we take the same prefix, and instead of ending it in ane for an alkane, we end it in ene for an alkene. And why are these names so ridiculously similar to each other? I don't know. I didn't invent them, but we're stuck with them anyways. So the prefix prop would give me the alkene of propene. And the prefix but would give me butene. And the prefix pent would give me, no big surprise, pentene. So how are we going to name our alkenes? The process is the same as it was for our alkanes. The thing we need to recognize is we've got something special in our alkene. Our alkene has a double bond, and that double bond is considered to be a special site. And so we have to make sure, for starters, we have to make sure that the parent chain includes the double bond. So before we just made the parent chain whatever the longest chain of carbons was, and that was great, except double bonds are special, and so we have to make sure that the double bond is on the parent chain. So if I look, for example, at this example here, there's a few different ways I might draw my carbon chain, but the longest carbon chain that includes the double bond would be this one right here. So that has to be my carbon chain. So the parent chain, we're going to number the atoms just like we did before. So we're going to number them off, 1, 2, 3, 4, 5 in this case. But we want to number them off so that the double bond gets the lowest number possible. So the parent chain carbon atoms are numbered so that the double bond gets the lowest number possible. And so in this case, if I start from the right and start numbering across 1, 2, 3, 4, 5, then I can see that the double bond is going to have the lowest number when I start to number this off. So the position of the double bond is indicated in the name by stating the number of the first carbon in the parent chain that the double bond follows. And then after that, we're going to name our branches. So just taking a look at this right here, my parent chain is 1, 2, 3, 4, 5 carbons long. It has a double bond in it. So 5 carbons means it's going to be pent. It's got a double bond, so it's pentene. I need to tell you the position of that double bond. That double bond could be anywhere. So in this case, this is 1 pentene, and we've got most of it, except this also has a branch sticking off of it here, and we can see that that branch has 2 carbons in it, no double bonds or anything, so that is an ethyl branch. There's a 2 carbon branch, and that occurs on the 2 carbon. So this would be 2 ethyl 1 pentene, and that would be my name. So I've got a couple here to practice, and you can go ahead and just try these and see how you do, and then unpause the video and come back and see how that went. And now that you've tried them on your own, and now that I'm not on pause anymore, let's give it a shot. So fairly straightforward because there's not a lot of branches here. I mean, there is only one parent chain to worry about. That's my carbon chain. I'm going to number this so that this double bond is the lowest number possible, which means I'm going to start from this side and go 1, 2, 3, 4, 5, 6. A 6 carbon chain would be a hex. It's a alkene, so it's a hexene. And then the position of the double bond, remember we'll choose the lowest of the 2 numbers. So I know that the double bond is between the 2 and 3 carbon, but I'm going to call this 2 hexene because I want my number to be as low as possible. And I don't have any branches to worry about, so that's it. That is just a molecule of 2 hexene. Now over here, I don't have branches, but there is something a little bit funky going on here. I can see there's my carbon chain, so that's pretty straightforward. But now I've got 2 double bonds. So how would I communicate to somebody the fact that there are 2 double bonds in this structure? Well, I'd start off with the parent chain. That's 1, 2, 3, 4, 5 carbons. So that's going to be a pent. And if I just called this pentene, well, then you might be under the impression that there's 1 double bond. But there are 2 double bonds. So I guess I'll number this off in such a way that we can see what my double bonds exist on. I've got 1, 2, 3, 4, 5. So I've got a double bond on the number 1 carbon, and I've got a double bond on the number 3 carbon. So maybe I'll call this 1, 3 pentene. But if I call it 1, 3 pentene, then I'm a little bit confused because is there only 2 double bonds or could there be more hiding somewhere? So I'm actually going to call this pentadiene. And the di, remember, that's what we use when we've got more than one of the same thing. We use the prefix di. So I'm going to call this 1,3-pentadiene because it's a double alkene. Okay, so let's go ahead and look at alkynes. Now, alkynes are just an extension of this. If alkenes are what happens when we have a double bond, then alkynes are what happen. Alkynes are what happen when we have a triple bond in a carbon chain. So a triple bond is again another opportunity for 2 carbon atoms to form a bond. If the carbon atoms form a bond with each other, then they can get rid of 2 hydrogen atoms. They don't need those anymore. So the general formula for an alkene is going to be CnH2n now minus 2. So this is a very much unsaturated. There's 2 places, or I should say 2 situations where we could add more bonds, and that's the triple bond. So in naming our alkynes, it's going to be the exact same, except the ending will be "-ine" instead of "-ane" or "-ene. And so if I have the same prefixes, for example, 2 carbons would be eth. Then if I have a triple bond, then this becomes ethyne. If 3 carbons, it's prop, which means I'd have propyne. 4 carbons is bute, so butyne. 5 carbons is pent, so pentyne, and on and on and on and on. Okay, don't need to go further than that. So I want you to go ahead and try these ones just on your own. See if you can give this a go. Follow the same rules we did for alkenes. Hit pause, give that a shot, see what you come up with. I'm sure you've done that. And now here's our answers. So just like with alkenes, we have to have the triple bond in our longest carbon chain. So the longest uninterrupted carbon chain would be this one straight across here. I'm going to number these so that my triple bond gets the lowest number possible. So I'm going to start with the number 1 here on the right, 2, 3, 4, 5. And so I can see I've got a 5 carbon chain, so this is going to be a pent. It's got a triple bond on it, so it's a pentyne. The location of that triple bond is on the number 1 carbon, so this is a 1 pentyne. Now I'm not quite done because there is a branch here. It's a single carbon branch, so that will be a methyl group because it's a single carbon, and it's located on the number 3 carbon, so this would be 3 methyl 1 pentyne. Good fun. Let's try this next one here. I'm going to look for the longest uninterrupted carbon chain that includes the triple bond. So I have to start here, and I think it's going to be 1, 2, 3, 4, 5, 6 is the longest that I can do. So I'm going to number these off so that I've got the triple bond with the lowest number possible. So 1, 2, 3, 4, 5, 6. So I've got a 3 carbon chain for my parent chain, so that's going to be a hex. It's got a triple bond, so it's a hexyne. The triple bond is on the number 1 carbon, so it's a 1 hexyne. Now I need to name my branches. So I've got 2 branches to deal with. I've got an ethyl group on the number 3 carbon, and I've got a methyl group on the number 4 carbon. And for some reason, the rule is we're going to name those alphabetically. Go figure. So the first one, the ethyl, comes before methyl, basically. So this would be a 3 ethyl, 4 methyl, 1 hexyne. And that's my alkyne. Okay? So that is it for alkenes and alkynes.